Hey guys, we're going to do something a little different today. We're going to start with 2-minute quiz. I'm not going to waste your time with that. All right, how about you hit pause and try to answer these 3 questions and then come back and we'll look at the answers. Okay, let me clear a little space there. Okay, so the first one here, I went with the one sample t-test, and that's because I have a known population, but I'm using the sample standard deviation rather than sigma, rather than the population. So when I use the sample standard deviation, that means I need to switch to a t-test. Down here, type 2 error, what that would be is failing to reject the null hypothesis, saying that the groups are the same, in other words, when in fact they are different. And of course, we never know for sure if we've done a type 1 or type 2 error, but I did tell you in the last video that there are many things you can do to prevent or reduce the likelihood of type 2 errors. I know we could do 3 things here. So for number 4, I said use a large sample size. That's the easiest one usually. Make sure you use a reasonable alpha. You don't want to get a too conservative alpha, especially if you're new to the research. So 0.05 is usually better than 0.01 for that. When you can, if you have some sort of background research or knowledge that allows you to predict the changes going to be in a specific direction, you can do a one-tailed or directional test. And then finally, in some cases, you can increase the size of the effect. Remember, effect sizes usually result from dosage, and in this case, I don't know how I can increase the dosage of anything because we're just measuring people's attitudes. So may not be able to do that one in this case. All right, well, moving on here. We're moving into 2 sample t-tests. So far, everything we've done has been with one population that we know about. But most research, like in drug research, for example, you wind up not having a population, but you wind up having 2 conditions. So like in randomized controlled trials, you have a condition where people are being medicated and a condition in which people have placebo treatment. And it turns out that those are a lot more common, doing 2 sample group experiments. And I want to show you today that there are 2 different ways of doing that. And starting here in chapter 9, is a dependent samples t-test. The textbook calls it repeated measures, and that's a synonym, but I wanted to use that just for the contrast today, because we will also be talking about independent samples, which is chapter 10. So the reason I had these pictures here is that they represent the differences between the 2. Now down here, if this is a drug study, that group might have the placebo and that group might have the drug. And if I picked someone out of this group, let's say that guy right there, it doesn't tell me anything about anyone in that group. In fact, when I'm done, my t-test will just compare the average of the group to the average of that group and see if there's an overall difference. But in dependent samples, notice how they're lined up here? There's something about those 2 guys that have them matched up. So rather than just taking the mean of all of the orange shirts and subtracting the mean of all of the green shirts, I'm going to subtract that guy's score from that guy's score on down the row and then find the average of the paired differences. So those guys depend on each other. So let me just show you what that looks like in English. With independent samples, I'm putting that first because it's a little simpler. The idea is that you have an independent variable that creates 2 separate conditions. So you have 2 samples, and the same dependent variable would be observed in all. So it would be like a drug versus placebo. Everybody gets their blood pressure measured. And nothing here specifically connects any one person to any other person. So you just have the 2 groups. Now, this one starts out the same. You've got the independent variable which creates 2 conditions, so maybe a drug and placebo. Everyone has the same dependent variable regardless of condition, so that would be like measuring blood pressure, except in this case, the researcher goes out of their way to show a connection between an individual in this group to an individual in that group. And there are several ways that can happen. We'll get to that in a minute, but first let me explain why you would do that. This is actually a more complicated procedure, so why would you make life more complicated. Oh, wait, hold on. Let's do this first. I just want to see if you can identify which one of these is independent or dependent, so hit pause, take a look at that. Okay, hopefully you paused and tried this. The first one says that the sample of blood pressures was given to the same people before and after, so it is dependent. That's repeated measures because every score in this group is connected to a score for the exact same person in the other group. This one is independent because they don't give us any information about individuals being matched or repeated measures or anything like that. So we have to assume they're independent. All right, now let me explain to you why we have dependent samples. It is more complicated. The reason is because of something we call individual differences. Individual differences in humans are just things like personality, different genetics, different educational backgrounds, and things like that. So let's say I'm doing a study, and I go back to Cassie's hypothesis about stair climbing. I could do a treatment condition where people go up 4 flights of stairs, and this would be a placebo condition where people were assigned to go up the same height, but on the elevator. Now, before I even start the study, I might wind up with something weird. Now, normally you would hope that randomizing people gets rid of this effect, but if you look at this group, before the study even begins, they're still sitting in the classroom, their average is 67.5, and the elevator group before the study even begins has an average of 78. And it's because that jerk right there with tachycardia is ruining Cassie's study, and doing it actually in 2 ways. The easy thing to think of is this group is already 10.5 beats per minute higher than the other group before anybody even got up out of their desks. So that's going to make the stair climbing, which we know from past experience has a big effect, it's going to make the effect seem smaller because this group already has a really high rate. The other thing that does is it really expands the standard deviation. Notice here everybody's pretty close together. There's not much deviation, but that's going to give a great big standard deviation. And that makes t-tests harder to be significant. All right, so what we're going to do when we have the chance is we'll try to control for individual differences. So here, if we get that person with a rapid heart rate, that person will affect both conditions. But in this sample, I wound up getting pretty typical scores. So let's imagine this is the stairs and this is the elevator. I got my random selection of 4 people. Notice that on Monday, I've got 2 people who are going to do the stairs, and 2 people, 66 and 70 here, are going to do the elevator. And the next day, they're going to come back and do it again, and they're going to just switch conditions. So person 68 is compared to his own score in both conditions. Person 66 has a score in both conditions. Now, these are their resting heart rates, and the reason I have the resting heart rates here is to point out that what we're trying to control for, the individual difference, is that people have pretty wildly different heart rates at times. All right, so that's what we would do. Now, I want to point out that there are different names for this. I've already alluded to that a couple times. The dependent sample studies are sometimes made up of different individuals. So the book refers to it as repeated measures, but the same statistical technique is used with what's called a matched design. So matched design means that I think that there might be something that influences my dependent variable, and I don't want it to influence my study. So what I could do is every time I randomly selected someone for the stairs, I could get the person's age, gender, body mass index, whether or not they're an athlete, and try to find someone else that has those same individual qualities and put them in the other condition. By matching up the people according to those tricky individual differences, I can get rid of some of that influence. So it's called a matched design or a paired sample. Those are the same thing. Now, in genetics, when genetics is involved, sometimes there are twin studies in which you have identical twins. in two different conditions to see how drug interactions or things like that might interact or differ. Now, those are all with different individuals. Sometimes you do the same individual twice. The two main terms you'll hear used in statistics are within subjects and the title of Chapter 9, repeat of measures. And then outside of statistics, you hear people talk about before and after studies in the media. These are all different ways of doing dependent samples. It's one type of t-test that is applied regardless of which word you're using to describe it. So these are just names. Okay. All right. Now, the final thing that I want to do is show you how to decide what t-test to use, or which test to use, including Z. So in this unit, we're actually looking at 4 tests, and I've created a little decision tree here. I think it would be good for you to write it down and kind of create a little guide for yourself. So at the end of the screen, why don't you pause it and make sure you have it down. Anyway, if I was to do a homework problem or a test problem and someone asked me which test should I use, the first thing I would ask is how many samples are in the problem. So when we started out this unit, in each case we only had 1 sample. And that means if I say only have 1 sample, that means I know a population mean. We've been using this guy as our population mean. So that narrows it down, but then I have one more question is, do I know sigma? Well, if I do, then I can do that one sample z-test. So if I have a sample and I'm comparing it to a known population with a known mean and standard deviation, it's the z-test. But if I use the sample standard deviation, it'll be the t-test. These are the one sample tests. All right, down below here, what if we have 2 samples? We have 2 samples. The next thing I usually ask is, well, are the individual scores connected in any way? In other words, if I pick out a person from this condition, can I match them up with another person in that condition? Most of the time you can't. And in a description in a research paper or on an exam or an homework, the writer would have to go out of their way to describe they did that. So normally it's not, in which case you would do independent samples. But if they are matched, then you would do dependent samples. So why don't you hit pause there, copy that down, and make sure it makes sense. And then we'll take a look at a couple exercises to let you apply this. Okay, now I got this activity here shows that pretty much any research question you have, do Augustanas have good ACT scores, for example? You can address that using all kinds of research techniques. And so what I wanted you to do is kind of see that and see that choosing the right test is a big part of doing research. So hit pause, read through these, and see which of those 4 tests would apply in each of these situations. Okay, now that we're back, let's see. The first one, I said a z-test. This is a one sample z-test because we're taking a sample of students and comparing it to the mean and standard deviation of the population as published by ACT. Now, incidentally, you can use a one sample t-test. In fact, programs like SPSS would always use a one sample t-test. But the z-test has more power than the t-test. And so in this situation, it would actually be to your benefit to use a z. If you said one sample t, that's still fine though. This one here, I said it's independent samples. I can see that because there is a sample from Augustana and a sample from Ambrose, and I'm looking to see if there's anything connecting any individual student from one school to the other, and I don't see that at all, so I went with independent. Finally, down here, we again have 2 samples, one Augustana, one Ambrose, but this part right here shows you what a matched or paired design is. In that case, the individual differences are things like educational background, family background, and things like that. By trying to hold those constant as much as possible, that allows the person to use a dependent sample t-test. So that's matched by individual differences. All right, I'm going to show you one more. I'm going to let you hit pause and look at that. And come back and I'll put the answers up. And that's it for today.